By now, we know how to determine the principal stresses, and the location of the principal stress is determined by 2 root theta P1 and theta P2 with the equation already have, and also sigma 1, sigma 2 equation. And at that principal stress plane, we have the tau, the shear stress equal to 0. And now, like a cow member, we have tau max equal to half of sigma max, as you can see here at 45 degree. In the any general loading that we want to determine, we also want to find out, okay, so what should be the maximum in the plane shear stress, and that is the topic we cover for this video now. So that now move on to the maximum in plane, so 2D shear stress. So what do we have when tau max occurs? Tau max, that's what we want to find out, occur when what? Same as here, we take derivative to find out principal, and we have tau equation. If we take the first derivative about theta for the tau x apostrophe y apostrophe, get the max, then it equal to 0, then we'll be able to find out tau max. So from that, we can do exactly the same when we have first derivative of equation tau x apostrophe and y apostrophe as we saw earlier over the angle theta equal to 0. So that what we have, first derivative, basically slope equal to 0. So we don't want to continue again start at page 441 in your textbook. I just say insert some mark here if you want to broaden your knowledge in terms of the math. Apply the math to find out that derivative here. So your job here. And if you are not sure, again, go and make a happy face so that you can have motivation. Go to read the book, okay? Either with happy face. Let's continue. After you insert your math or read the book, we can see that tau max equal to square root of sigma x minus sigma y over 2 square plus tau x y square. And if that is x and y, if we use in the principal stress sigma 1 and sigma 2 in that equation, so we can even simpler if we use that. So if we already find out sigma 1 and sigma 2, so we have sigma 1 and sigma 2 instead of sigma x and sigma y. Based on the both equation, tau max is much easier. Tau max equation is only sigma 1 minus sigma 2 over 2. Why? Because at the tau xy, the tau at the principal stress equals 0. So you have that 1 for the equation. So let's block that equation. If we apply directly from the original coordinate x and y, if you already find out the principal stresses, tau max can be determined. Either equation should get the same answer, and that is the shear stress. So what is the normal stress in the plane that have tau max? So as you can see here, for yes, at 45 degree, tau get max sigma. It's not 0. It's not max. It's not mean. It's something. What is that? So that is the next equation that we want to find out. So the normal stress when we're talking about the maximum for the in-plane shear stress. So in this case, the normal stress for that one, normal stress, in this case, it equal to sigma, happen to be called sigma average. Sigma average, it equal to sigma x plus sigma y over 2. Over 2. And let box that equation as well. So when it get the maximum shear stress, the normal stress equal to sigma average. So let's stop here for the lesson. We go to the worksheet 12A and B. We already practiced 12C previously, and then continue with the lesson.